Now we want to look at these graphs just to identify the type of symmetry that we're seeing. So we've already talked about y-axis and origin symmetry. There's also x-axis symmetry, where you would have a match across your x-axis. So let's take a look at 13 and 14 to start with. For number 13, if we're looking for y-axis symmetry, that would mean for every xy ordered pair, there should be a matching negative xy ordered pair. And I don't see that. I don't see a match from left to right across my y-axis. So no, we don't have y-axis symmetry. If we have x-axis symmetry, then for every xy, we'd have a matching x negative y. And I do see that in this case. So for example, we have 4 and then, I don't know, maybe 2.5 it looks like. Something like that. 4 and something like negative 2.5. So we have the matching 4, the matching x values with the opposite sign y values. Okay. Here and here, here and here. So yes, we do have y-axis symmetry. And then origin symmetry, for every xy, we should have a matching negative x, negative y. So here it looks like we have a 2, 2. That means we should have a matching negative 2, and we don't. So I don't see origin symmetry. Okay. So for number 13, it doesn't have y-axis symmetry, which means it's not even. It doesn't have origin symmetry, which means it's not odd. And what type of function is it? It's actually not even a function, right? It fails the vertical line test. Fails the vertical line test. So number 13 is actually not a function at all. It's not even, it's not odd, and it's not even a function. All right, if I look at number 14, y-axis symmetry, I do see symmetry across the y-axis, this point and this point, right? The opposite sign for x values with the same y equals 0. I've got this point versus this point. So you can imagine folding this in half across the y-axis and having an exact match. So yes, I have y-axis symmetry. I don't see the same matches above and below the x-axis, so I don't have x-axis symmetry. And I don't see origin symmetry either. So it's not exactly this point, but let's call this, 1 and negative 2-ish, something like that, 1, negative 2-ish. So then I should see a negative 1, positive 2-ish point up here, but I don't. So I also don't have origin symmetry. So because I don't have origin symmetry, I know it's not an odd function, but I see y-axis symmetry. So this is an example of an even function, and I can tell that graphically. All right, number 15, y-axis symmetry. It doesn't look like I have matches all the way across, left to right. So no y-axis symmetry. So for example, I have this 1, negative 3, so I should have a matching negative 1, negative 3, and I don't. X-axis symmetry, same thing. I don't have matches above and below my x-axis, so no. But when I'm looking at my origin symmetry, this is where I might have something. So I have this point 1, negative 3-ish, and I see I have the matching negative 1, 3. I have the 2, 0, the negative 2, 0. So it looks like for every xy, I have a matching negative x, negative y. So I can see those matches across the origin. So yes, I have origin symmetry. So because I don't have y-axis symmetry, I don't have an even function. But because I do have origin symmetry, I have an odd function. And for number 16, now I have yeses all the way across, right? I have y-axis symmetry, I have x-axis symmetry, and I have origin symmetry. So what kind of function do I have? Is it even, odd, or neither? Well, actually, this one isn't a function at all, just like number 13. This one isn't a function at all, right? So symmetry everywhere, but definitely fails the vertical line test. Fails the vertical line test. So this is not a function. So we can't talk about whether it's even or odd. It's not a function.